So hello everyone again. So my name is Halim Busada and I'm an instructor here. We are trying to democratize and help everyone or reach the tech industry. So a small history about SHA. We started 4 years ago as a offline school, and then when the pandemic happened, we immigrated to start as a fully online school, and that actually helped us reach more people from all around the world. I am so glad to host you today. And today's webinar is about development cloud and using serverless technology. We will be today with Ali. Ali, can you please present yourself?
Yeah, hey everyone. So this is Ali. I'm going to give this session today. I actually had like my first slide, just a small introduction about what I do. So should I start sharing my screen?
Yeah, you can share your screen. And for the question, guys, you can send a question on the Q&A and I will be redirect them to Ali.
Cool. So can you see my screen at the slides?
Yes. Yes.
Yeah. All right. Cool. So hi everybody. So yeah, obviously my name is Ali Haydar, and I'm gonna talk through the session today. First, I'd like to thank the Social Hackers Academy for the opportunity to share some of my learnings. And I'd like to thank everybody who's joined the session. I hope it's gonna offer some tips that you could use in your project or at work. And I hope it's not gonna be boring. Cool. So a bit about myself. I am a software developer. I live in Auckland, New Zealand. My career is not very traditional. So I started early as a tester and then moved towards product and project management at some stage. It was a good experience, but I prefer to stay on the technical side of things. So to be more hands-on. Product management and project management could still be technical, but I just wanted to do more code and more architecture and development. So I made a move towards development, hoping to acquire a breadth of knowledge across multiple disciplines in the software industry. I work mainly with JavaScript and TypeScript, and I like to be involved in infrastructure. I am an AWS community builder. So this is a program offered by AWS, which I joined a couple of months ago. AWS provides mentorship and learning opportunities in this program, along with some other perks. It is very good, and I highly recommend it for people who are interested. At the moment, the applications are closed, but they are going to be open early next year, and I will be posting on this on social media. I work with a company called Multitudes, which has a great mission to enable happy and high-performing teams that are focusing on equity, diversity, and inclusion. Multitudes is an app that provides insights and recommendations based on data from tools such as GitHub. So the product's core focus is on the people aspect of work, such as psychological safety, well-being, and collaboration. So these are all leading indicators to high-performing teams. So you could request access to, we are in a beta stage at the moment, and you could request access to our beta and give the app a try, give us feedback if you like it or not, if you think this is useful or other things could be useful as well. Yeah, so finally, this is my LinkedIn and Twitter accounts. Please add me there and reach out if you have any questions or just want to say hi. Okay, so during the session I mentioned earlier to Halim, so please feel free to add your questions as I go, and in between every slide and the other, I'm going to also ask if anybody has any questions. First, like this session is we're going to cover like on a high level what is cloud computing and some of the cloud computing types. Then just a very high level overview. Then we are going to talk a bit more about a project that I had prepared, where we are going to use a few serverless components or services from AWS and go through how this works, how these services work, and then we can try together creating or utilizing some of these services. Then we will dig a bit more into some code and just like see how I implemented this simple project and to give a better idea of how things work. And I'll touch a bit on the unit testing there. Then if we still have time at the end, we'll touch a bit about a small idea around safe deployment in the serverless world in AWS. Cool. So cloud computing, what is it? So cloud computing is an overused term, and it means lots of things for different people. So when you ask multiple individuals what is cloud computing, you will get different answers, and now also another different answer. So AWS introduces cloud computing, like it defines it as the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. So instead of buying, owning, and maintaining physical data centers and servers, you access technology services such as computing power, storage, and databases on an as-needed basis from a cloud provider such as AWS. So here, just like we just mentioned something called IT resources. So what are IT resources, or what are resources in AWS? So resources in AWS go into multiple sections or multiple categories, and they cover compute, storage, database, network, and machine learning, and more. But the basic ones are these four. So I will give examples to compare these resources here into some real-world kind of cases or some real-world uses we happen to do like in on-premise. For example, the compute could be compared to CPU and RAM that are needed for a server to run at a certain power. So this is the brain power. So you use the compute category or the compute resources in order to create a server or a virtual machine, for example, or a piece of code that is going to run on the cloud. So this is the brain power. The storage could be compared to your hard disk. It's where you store your files or some objects, for example. Databases are exactly similar to data store that you configure on your local machine. Such as MySQL or Postgres. So the difference here is that these services are, or these database servers are on some cloud server somewhere and are managed by AWS. And here, only thing you need to do is to just set up your schema, for example, and interact with this database, access it, insert into it, or read data from it. And finally here, the network, it could be compared simply to your router or firewall that would stop access to a certain machine on your local network at home, for example. But here it is like you would set up a router somewhere on the cloud that would stop access to a virtual machine you have created on the cloud. In general, an AWS account is formed of resources and identities. So resources is exactly what we just discussed, such as database, virtual machines, network, storage. And identity is a user. A user is mainly like a human being trying to interact with these services or these resources, or it could be an application or a service that's going to interact with these resources through an application. So for example, if you have a mobile application that is going to read data from the database, then here there is a service that the app is going to use to access that database. And finally, so here, like just to finish this slide, so there is, I've set up like a small definition, which I relied on NIST, Wikipedia, and AWS docs for it. So it's just like what defines a cloud computing. So NIST is the National Institute of Standard and Technology, so which is a part of US Department of Commerce. So NIST creates standard documents, and one of them is this special publication about cloud computing. So it has like more very detailed definition around what is considered cloud computing or not. So the first thing is that to be considered cloud computing is the on-demand self-service. This means that no human interaction is needed to create the resources, such as the storage or DBs or virtual machines. So you don't need to contact, so this means you don't need to contact AWS to create a new server for your web application. You can do this through a button click on a website, for example, and you don't need to inform anybody in AWS. Second, so resources created should be accessed through normal protocols, internet protocols such as HTTPS and SSH. So if you created a database, you should be able to access it normally as you access any web application. So this is second. Third, capabilities can be elastically provisioned and released on demand. So what this means is that for example, you don't need to buy a server with a huge memory or CPU beforehand so that you cater for an increase of usage in the future. So you just buy what you need, the resource you need, and you set up some scaling. And so that server scales up as the usage increases, and it scales down when the usage decreases. So this is the third item to be considered on cloud. So it's scalability, mainly. And the fourth one is that the resources usage are measured. So here we should have some monitoring in place, and we should be able to report on how and when a scaling is happening, for example. So we should get a clear idea of on the cost according to that scale as well. So here it is possible to control this usage as we need. So for example, control how much to scale in or out. For example, you could, set up the lower scale is to have 0 servers running. So if you don't have any user that are hitting your servers, so you just turn it off. So and then you could set it as 0 servers or 1 server, and you can scale it all the way up to 10 servers. You can specify these kind of numbers, and you can monitor what time this scaling is happening or not. So this is also some kind of a characteristic of cloud computing. Anybody has any questions?
For now, I think no. We didn't receive any questions.
Yeah, this is still a theory, so sorry about that. Yeah, cool. So now we will talk quickly also about the types of cloud computing. So here we have 3 types of cloud computing, and these types are infrastructure as a service, platform as a service, and software as a service. So the infrastructure as a service, this is when the cloud provider, when we say cloud provider, that's AWS or Google Cloud or or Azure. So this is when the cloud provider gives you the ability to replace your physical server with a virtual one. So as a developer, you would care about installing and managing the operating system and the runtime. So for example, if you need Node.js and the implementation as well. So here, instead of utilizing your local machine, so they've given you the machine, they've given you the data center, and you just create your application, set up the operating system and create your application. A platform as a service is when the cloud provider takes care of managing as well the operating system and the runtime. So here you don't even need to install Node.js in case you want to create an application with Node.js. The cloud provider takes care of it. And here the developer only needs to worry about the data and the implementation. And this is really great for startups because this really accelerates their work. They don't really need to worry about anything like behind the scenes, such as operating system and servers and all of that. And here, SaaS, so software as a service. So here you have a complete product. So you just need to think how to use the particular software. So it is like a product that you could use out of the box. For example, an email client. Gmail, for example, is a software as a service application. Cool. I assume no questions here as well. Cool. So let's create a VM together just to show an example of infrastructure as a service. So here I have, this is the AWS console. So the first time you open the AWS console, you would see this. And here I have recently visited services. When you logged in first, you won't see any of these services here. So you would go to search for the service you would need here. So we are going to work with a service called EC2. EC2 is the service that enables us to create virtual machines in the cloud. It enables us to create also other kind of resources such as load balancer and all of that. But at the moment, we are going to just demo how to create a virtual machine.
I think we lost your sharing. Hello, Ali?
Yeah. Can you hear me now?
Yes, we can hear you now.
And can you see my screen?
Yes, we can.
Yeah, I'm not sure what happened. My computer froze a bit.
It's okay.
Okay. Yeah. So now, like, we are in the EC2, and then we create launch instances. So this is how we create a new virtual machine. And as you can see here, we have a list of operating systems that we can use, such as Amazon Linux, 2 AMI, and then another Amazon Linux. So here, these are operating systems that were customized by Amazon. We have here, for example, a Mac OS operating system, another one. And then if you scroll down, you will see like lots of other types of operating systems from Linux to Windows as well. So you just go and create the virtual machine that you would need there. You could see here free tier eligible. Okay, so one thing I'd like to note, just in case for people who haven't used AWS in the past. So please, when you create your Amazon, your AWS account, the first thing that is really highly recommended to do is that you create a billing alarm. So some of the services could be free for the first period of time or for a certain period of time, but some other services are not free, and then they might have some kind of cost. So it is really recommended that when you log in first, you go and create a billing alarm. This billing alarm, you could set it, for example, for $1. And then in case, for example, you created a virtual machine and you forgot to delete it afterwards, then it's going to start using your money, right, on your credit card. And then here, if it reached this $1, then it's going to send you an alert around this. And then you remember, oh, I need to turn off that machine, just so that you don't end up like kind of wasting like hundreds or thousands of dollars on your credit card, okay? So this is like a note I'd like to mention. So there could be some cost when you are trying these. So here I'm going to create this kind of operating system. It is a Linux operating system. And after I selected it, so here it has presented me with a list of possibilities of resources. So you see here, we can create a virtual machine with one CPU, 0.5 gigabytes, one CPU, 1 gigabytes, and so on. And it could go like a lot. So 8 CPU, 32 gigabytes. We can have like some very heavy and expensive virtual machines created here. And all of them are attached with some EBS, which is the hard disk mainly. So here I'm going to select this one because it is free tier eligible. And then I'm not going to go into more advanced details for the configuration. I'll just review and launch it. So here is the review. I click the launch button. Here it tells me to select, to choose an existing pair. So this is a pair, it's a key that will allow me to access this machine or to log into that machine through SSH. So I have already a key that is prepared, but if you don't really want to access it from your local machine, you don't really need a key. And then you click Launch Instance. and here it is created. So now you will see the instance. It is kind of being created, and it takes like a minute or two to actually start. While we are waiting, anybody has any questions so far?
Still clean.
Oh, yeah, awesome.
Okay, just a reminder for who joined later, you can ask any question at any time in the Q&A part, and I will redirect it to Ali. Okay, we have...
I think some people are writing in the chat.
Yeah, so they are just saying that everything is clear and it's very good. From Gerald.
Yeah, beautiful. Yeah. So now you can see that it is running at the moment. So what we could do, for example, is we could right click on it and then click connect. And here, there are like multiple ways to connect. So if you are wanting to connect from your local laptop there, then here are some steps on how to use this key, which I mentioned earlier, so that you connect. And there are like multiple ways to connect. Here, I'm going to use the simple way, which is EC2 Instance Connect. So I'll just click the connect button. And as you can see here, it opened a new tab, which contains like a shell in it.
Ali, I think, sorry for interruption, but I think we have a question. Ammar, he's asking, EBS stands for what exactly?
Elastic block storage. So this is kind of, think of it as your hard disk, which is attached to your laptop, but it is on the cloud. And then, so you could define, so elastic block storage, so you could define it as SSD or HDD. And here, like, for example, there are maybe other kind of options as well, but these are the ones on top of my head. So so this, you define, for example, how fast you would want your hard disk to be and how performant. Yeah.
Hope that made it clear, Ammar.
Yeah, awesome. Cool. So here, like you see, this is the instance. We just logged into it. And if we do, for example, the command ls, then you can see, so ls is going to list all of the folders and file within a directory. So if we do pwd, it's going to tell us we are under this directory, which is called home EC2. So we could do, for example, touch. So here when we say touch test.txt, so we are saying we have created a new file called test.txt. So if we do ls again, so here is the file, it is test.txt here. So we could do, for example, a vi test.txt as well, and we can write in it, so social hackers academy, awesome, right? And then here we can do get out of it, I'll clear the shell, and then if I do ls, the file is still there. If I write cat test.txt, then here it's going to display whatever has been written inside of this test.txt in it. So it just displayed what we've written there. So what I'm trying to demo here is, it is like a super normal Linux operating system, Linux machine. It has 1 GB of RAM and 1 CPU, and it works properly. So we can go and install Node.js here, install any type of servers we would need, and start our application. So I will exit now if there's no questions. Cool.
I think it's all clear.
Yeah, so I close this virtual machine here, and so I'm logged out. So what I'll go to the instances again, and yeah, 1 second. Here I'm going to just turn it off. So I'm going stop instance. So stop instance is not going to delete it. It's going to just shut it down, but it's still going to be there, and you won't be charged for it. If you do terminate instance, it's going to shut it down and delete it, and it will delete the hard disk with it. So here I'm going to delete it because I don't really need it. Okay. So this is for EC2. And now I'll go back to the slides. Cool. Any questions? Cool, I'll take a sip of
It's all
coffee.
clear. I think your laptop is just freezing a bit, but other than that, I think it's all clear.
Yeah. Sorry about that. I think I need a new laptop.
Okay, so I think we have a question, meanwhile.
Yeah.
From Maria. So
Yeah.
she's asking, how is it possible to associate our server to a given domain name so that it is accessible from everywhere?
Yeah, that's a very good question. So first you would need to buy the domain. So that you could use a service in AWS called Route 53, so that you buy and register your domain name. So this is the first step. And then the second step would be to create, so you have two options. You create a route inside of Route 53, so that when this domain is hit, it's going to route the requests into the instance. So the instance has an ID and has like some kind of a name as well. So from Route 53, where you registered your domain, you just like create a route record, and then this record is going to direct the request there. If you were in a bigger scale, you add a load balancer in between the VM, which you created, and Route 53. And you could create two, for example, VMs here in case you wanted to spread the load, for example, of your requests across multiple virtual machines or multiple servers. So from Route 53, you configure your record to route the requests into this load balancer, and the load balancer decides on its own where to send the request, to VM1 or to VM2.
Okay, hope that answers your question. Maria said thanks, so I think that answered the question.
Yeah. So Route 53 is a totally also big like kind of service in AWS, and it is all about the domain name system and how it works. But it is also simple to use, but also remember that it also has a cost. So when you try it out. Okay, cool. So now I'm going to talk a bit about serverless, and this is one of my favorite topics. So, yeah, cool. So gentle introduction into serverless. So over the past few years, serverless architecture has become very popular. And this is largely because it removed lots of the burden of managing infrastructure, such as servers, storage, database, and scalability, and so on. When people first started talking about serverless or using the term, so it created some confusion a few years back. And some people joked, how are they supposed to run apps without servers? So the servers are still there, and they still exist, but their management is now, their management and operation are now handled on your behalf by the cloud provider. So AWS just takes care of everything. So so here it is like a platform as a service in this case. So everything is there. So AWS takes care of setting up the operating system. You don't really care which operating system is working on. So AWS sets up the runtime. So here, if you are working with Node.js, then you just like configure it and AWS will take care of it. If you are working, let's say, with Python, then it uses some kind of Python server and it takes care of it. So mainly that's how it works. So using serverless architecture enables organizations and engineers to focus on what is important. And I also remind here that this is great in case of startups as well, but also like some very huge scale companies are using it. So here you focus on what is important, which is building great and performant and cost-effective applications that stand out in the market. And this kind of a bit faster. One thing I'd like to note here is that while serverless introduces a lot of simplicity in the process of building and shipping software, there are some challenges that come into play around testing. So first of all, testing locally is complex because serverless apps are dependent on cloud services. So this is true for both unit test and integration test. Because like in this case, in order to do this kind of testing, you would need to start mocking and stubbing services to make sure that the application is working correctly. Okay. And even though this might be a bit of additional work, it provides better way to test in isolation. So this is in my opinion. Some other people wouldn't prefer to do the mocking and would like to test with the real services, and it is totally fair. Second, around the integration testing. So so around integration testing, tests become more difficult because there are multiple services and components that need to integrate together, and the risk here is more around the configuration. So if you make some configuration mistake, then here you wouldn't be able to, so you would need to test it a bit more. So this added a bit of risk in addition to the risk which already exists in case you made a bug as part of your code. So there's a configuration bug and risk, and there is a code bug risk as well. So any questions?
Yeah, sure. We have two questions. The first one is from Selena. She asked, is there any technical support available regarding AWS documentation or something like that? Yeah,
so there is lots of AWS documentation. The AWS documentation is huge, so sometimes it might be overwhelming to just like to know where to start. So here, like usually how I got started is through online courses, and then I started going to meetups. As I mentioned earlier, this kind of community builder program that they do, for example, is very helpful because you get mentorship from people there. They kind of try to ask you, try to give hints on things. You can ask your questions there. But yes, there is lots of documentation there, and which you could go. And I mean, like if you haven't worked with AWS in the past, you need to start with a get started, and this will tell you how to create an account. But yeah, so it is something that you start with, creating an account, setting up the billing alarm, which I mentioned earlier, and then moving on into some services. And it depends. So for example, it depends on each person, to be honest. So some people like to have a project in their mind and they would like to implement it. And here, like, it is a good idea to just try serverless. So you could say getting started with serverless, and there's like heaps of documentation on AWS on how to start with that. And here I'm going to start explaining a few serverless components. So if you'd like to implement your projects with serverless, then now like this could be a great starting point to know which components to use, and then you can get later into the depth of each component on its own. And also, please like send me any questions if you have. Yeah, so mainly that's it. For other support, if you are a company, for example, and you would want support, yes, they do. I mean, even if you are like an individual who has an account, you can ask support, but this is more of a technical support, right? So in case something went wrong or you didn't know, you couldn't like access your account or something, but here they wouldn't be through this channel, they wouldn't be helping out with kind of learning. Yeah.
Okay, thank you. So the second question is from Petros, and the question is, what about privacy and security?
Yeah, good question. Yeah, privacy and security is very important. At the moment, like everything is, okay, cool. I'm going to stop this and I'll go here. So first, around data in general. So here you can see you have in AWS lots of regions. So here you could select which region to go. And this is around data. So where you want your code to be deployed, where you want your data to live, in which region. So for example, in Europe, for example, you could have, if you are in London, for example, there might be some kind of rules or laws around the data to live in London. Okay, so here it might be that the company needs to store their data in London. And this is like how you can manage the privacy, because when you say the region is London, it means that all of the data centers of AWS are like located in London. You wouldn't know exactly where they are located, but you know, like there are multiple data centers, which they call availability zones, and they would be located around London. So this is a way to handle where the data live, and this might actually help with the privacy a bit. However, for the security, yes. So there is like lots of security that you could do around so the networking. So for example, you know, you could create a full set of network inside of your AWS account. By default, everything we create goes into something called Virtual Private Cloud, VPC, and everything is going to be created inside of this Virtual Private Cloud. So now this instance that I created is going to live automatically inside of it. If you start getting a very huge, so this is good for small projects, but if you're starting getting into a very huge like system, so here it is good like that you create your own VPC, and then you configure the IPs of this VPC, and then you configure the firewalls again around this VPC, and decide which IP could get into the VPC and which like kind of data could get out, for example. And this is how you manage it. It's not like a simple task, and it requires lots of thoughts and lots of architecture on how to do it. So for example, one of the things that is usually done when you create a virtual machine, or for example, assume you have a database, you put the database inside of this VPC, and then you don't allow anybody to access it. So, but how are you supposed to interact with this database? So you create a virtual machine. This virtual machine, you call it a bastion host. And then what you would do is that you do something called Ssh Tunneling, where you are able to, so you only give this virtual machine access to your database, and then through Ssh Tunneling, you go from your local environment into this virtual machine and tunnel all the way to the database to retrieve or to query. So there are lots of things around security. I'm not a security expert, but yes, there are lots of things that you could do around security, and mainly they start all the way from managing your network, and then they will go to the normal coding which you do, and making sure, for example, you don't have server-side scripting or something in your code. I hope like this kind of gave a bit of an idea.
All right, thank you, Ali. Actually, we have another question. Yeah. You have time. Okay, so this question is from Irena. She say, hey Ali, have you tried using Firebase? If yes, what is the best for newbies to use? Is it AWS or Firebase?
Yeah, I haven't like worked a lot with Firebase, but I know it's a good product. So it's a real-time database. I cannot talk a lot about it. Yeah, I think it's a personal choice probably. So everybody would need to try it out. Yeah, I cannot talk a lot about Firebase in specific because I haven't used it so much. I'm kind of very familiar with the AWS side of things, and because I got familiar with it, I think it's kind of getting simpler for me at least. And yeah, it depends. You could try both and then decide on your own. One of the services that I do like is in AWS is Dynodb database, which is also an NoSQL database, which I'm going to talk a bit more about in the coming few minutes.
Okay, thank you.
That's it?
Yeah, I think that's it for the question.
Okay, cool. I'll get into the services now and just show people a bit. So now I'm going to get a bit more into these services. So here we have 3 serverless services in AWS. So this is a Lambda, this is a Dynodb, and this is an API gateway. So I'm not going to get so much into the depth of API gateway because it is mainly just a gateway. It's a place where you define your API endpoints. So like which are going to be hit from the front end through request. So you get the request, it hits the API gateway. The API gateway has this endpoint. It has configuration around this endpoint, and it takes it and routes this request into some code that lives here or there in AWS. This code lives in the Lambda. and the Lambda is just a function. So here you would have like this API gateway routing the code into the Lambda. And the Lambda needs to interact with the database, and this database is the DynamoDB. So around DynamoDB, it's a schemaless database that has the following components. So it is a table, it has items, and it has attributes. A table is a collection of items, and each item is a collection of attributes. Each item has a unique primary key, which distinguishes each item from the other. The primary key can be simple or composite. Where the primary key is simple, it will be formed of a single key called partition key. In the composite case, the primary key will be formed of two attributes, partition key and source key. We can have as many attributes as we want inside of an item. And an attribute is a data element that doesn't need to be broken any further. Is Halim still there? Okay, can you give me a hint on the chat if you're still hearing me? Yeah, okay, cool, thank you. Yeah, okay, so here I will go and show you a bit about DynamoDB. So you just write here DynamoDB. Yeah, yeah, all good, thank you. Yeah, so you see here, we can go to DynamoDB, and here we have tables. And in these tables, so here I have created a few tables. It's just one thing I would like to note. So this is not a relational database. So the tables cannot be considered as table that you could join, similar to what we do in Dynamo and other databases such as MySQL or Postgres or Microsoft SQL. So DynamoDB is a single table database, and it is a document plus key value database. So it is not great to, for example, try to get data from multiple tables at the same time and join them. It's not very performant, and this is not how it's supposed to work. I'll give an example about this company's database, which is what I'm going to demo a bit if we still have time. So the companies, so I mentioned multiple items. So I'll click here on few items. Okay, it's frozen a bit.
We can't hear. We can't see your screen.
Yeah, it is loading. Can you see it now?
We see it loading and then black screen. Now we can see your screen. Yes.
Yeah. Sorry. Okay. Yeah, I think it will be something with the resolution as well. Anyways, so here we have like 3 records, and as you can see, we have done a scan operation. So this is not something that is recommended when you have a huge table to do scan operation. One thing I would like to talk about is how you define the schema of the DB. So, you know, when you are working with a relational database, for example, you have a customer and you have a product, so you create a table for customers, a table for product, and then you do a relationship with them, and then you do a join in between these tables in order to figure out like which customer bought which product, right? And you see like the structure is very generic. In this kind of case, when you decide to architecture, to create the architecture or the schema of your DynamoDB, you would need to understand first the business use cases. How are you going to access the data? So in this case, for example, I have a company ID and company type, and this is a combination of a primary key. So here I can only access this DynamoDB through querying company one, through querying this primary key, right? So if, for example, I wanted to get record by company name, this is not a good schema to do this. Why? Because if I want to get, for example, the revenue of Pied Piper, and I only have the name of Pied Piper, so what I would want to do is I would need to go and do query, scan all of the records, and inside of my code, I would need to start filtering on the records to figure out which company has the name of Pied Piper, and then get the revenue of Pied Piper. So this is not a great way to do it. It's not performant. So if, for example, I want to have Pied Piper as a queryable entity or attribute, then I would create it on its own attribute. And I have two options here. So either I put it as part of the company ID and company type. So this makes it like part of the primary key. So it's directly queryable. Or I create it as a new attribute and I add to it something called secondary index. And through this secondary index, I would be able to query it directly. Sounds good? Okay, and here you could actually see it. It is just like a JSON format. You could see here like the company ID, company type. You could add as much attribute as you want. And note something, when you are inside of DynamoDB, you can have each item has different type of attributes. So for example, it could be that I can add a company name and I add another attribute here, but this attribute doesn't have to be like really there, right? So this additional attribute doesn't have to be on company 3 and company 2. It could be just on company 1. So you could have 10 attributes on one item, but 9 attributes on the other, and 3 attributes on another item as well. Any questions around DynamoDB?
For now, no, we didn't receive any question.
Okay, because I think we are running out of time, so I'm going to go into the Lambda as well.
We can just leave the question for the last 5 minutes if you want.
Okay. Yeah, so yeah, okay. So here I wanted to show what is a Lambda. So a Lambda is a service that would allow us to just create code in the cloud. And now it is loading. Yeah, sorry about my laptop's performance.
It's fine. Like 80% of us are struggling already. So
yeah. So yeah, I think like it deteriorates as we have like a video call. This happens most of the time.
Yeah.
Yeah, so I wanted to talk quickly here. So you see, I have here functions, and I just create the function in the cloud, and I get it to run. So here, this is the company's data demo, which I mentioned. So here, if I go to create function, so if you do test function here, I'll call it test function, and then here you could see there is a runtime. So if you work with Node.js, you just select it. If you work with .NET, you just select it. Go, Java, Python, Ruby. There are too many others. And then here, I'm going to just click create function, okay? Yeah, it's just like a second, it will create the function. Okay, so here is the code that is being created. And when we say it's a cloud function, so that's mainly it. It's a function in the cloud. There is index.javascript file here, and there is a function called handler. It takes an event, and then here you do some logic here to implement your logic, and then it returns a response, hello from Lambda, and it returns the response. So for example, if we go here and we do console.log, and we do, here is my event, then you could do event, all right? And then we can now click save. And as you can see here, it told us changes are not deployed. So I just want to mention something. So you remember the API gateway, which I talked about? So API gateway, we will define the route there. The route is going to hit this exact Lambda here. And then once this Lambda is hit, then here there is the parameters which are on the API call, for example, are going to be received as part of this event here. And then we do the logic here to go and read from the Dynodb. Here I'm just doing returning, logging the event. And then after the results are returned from the Dynodb, we return them in the response as body JSON instead of hello from Lambda. So this is how it mainly works. As you see here, it says changes are not deployed. So I just click deploy. And now changes are deployed. It's super fast. And if I do test, here I would need to define the event. So if I do test event here, so these are the events that are going to be sent from the API gateway. So these are the keys, for example, that could be, that would arrive with our API request. And if I click create, so here I created the test event. If I click test, you see now it is loading the event. It returned a response with the status code. And then here, we did a logging. The log that we've done here is my event key 1, value 1, key 2, value 2, and etc. So this is the Lambda, and this is how it works. Yeah, how are we tracking on time, Halim?
I think we still have 5 minutes, but we can have an extra 5 minutes.
Okay.
If the Zoom link is already set for 1 hour, maybe we cannot surpass that.
Yeah, then let me just like finish within 1 minute, and we can have like a few minutes for questions. So I won't go into the bigger project, but I hope this was helpful. So here, like I just wanted to show how the architecture of the code is. So here, like how it works together. So you have a front end, you have Amazon Gateway, you have the Lambda, and you have the Amazon DB. So the front end hits the API gateway. The API gateway goes to the Lambda function, and the Lambda function hits the Dynodb, takes the data, returns all the results to the API gateway, which returns them all the way to the front end. So if we go here, just to show you a bit of API gateway, how it looks like. Yeah, it's taking a while to load. Yeah, so here you could see the company demo API, and here it has a few routes. Yeah, just loading. So you see here it has a company, and it has a get, it's a get method request, you see. So it's simply, you define your method request, and your method request takes a company ID. And then here you define that to route to Lambda. And you see here, this Lambda, if you like just turn your head a bit, you could see Lambda company's data demo live. So here it's just how it works. It is going to call the company data demo. So if I click company data demo, it's going to open my Lambda for me. So I think maybe that's what I wanted to cover. I wanted actually to get more into the code, but unfortunately there isn't enough time anymore to go more into how this project is working. So we spent like too much time just like getting into the services. I hope this was useful.
Right. Thank you, Ali. If possible, we can pass to the questions.
Yeah.
Right, so the first question is from Selena. She said the quality of internet connection is a prerequisite from what I understand, right? Otherwise, are there any limitations using the service?
No, there are no limitations. And yeah, I mean, the internet connection is like kind of a bit important, but I mean, yeah, it depends like how good or bad it is, like to just load the services and all of that. But it should be all right. Like you could use it anywhere with any internet connection.
Right. Second question and third question are from Petros. He said, so is it possible to combine multiple languages in one project?
Yeah,
I think.
yeah, it is possible. So for example, you see here how the Lambda is, I have created a Lambda with Node.js, right? But you could create this Lambda with Node.js, and especially nowadays, like microservices is very important and it's very well used. So you could create one function with Node.js, another function with Python. It depends on what you need, and it depends which language you are familiar with.
Okay. Next question is also from Petros. He said, can AWS support also small and big projects, because it is said that it's preferred to have a dedicated server for big projects?
No, it's not. You don't have to have a dedicated server for the projects. So here, like, there's something called I think it's called shared tenancy. So AWS has lots of servers and has lots of it's called resource pooling, in fact. So here, AWS has all of these services and all of these servers, and when you create a virtual machine, it just uses a tiny bit of the data center and all of these services from AWS. So regardless how small or big is your app, you could utilize AWS for it, or any other cloud provider, in fact. But yeah, AWS has all of these kind of abilities in order for you to scale down or scale up, have a big project, have a small project. I have very tiny static websites that are hosted with AWS, but I also have bigger projects that are hosted with AWS.
Right, thank you. Next question is from Ammar. He said, what technologies do we need to know to be able to enter or to work in this field?
Okay, so to get into AWS, so just like, it depends. So this is a bit like of a big question, and the answer of it cannot be small. So I'll try to make it as brief as possible. So here it depends what you want to do. So you could be like a system administrator or system operations, and here you could manage things around identity in AWS, and you can manage things around security potentially, and other kind of aspects of operations in AWS. And here, you don't really need to have a specific knowledge in a specific programming language. If you are a developer, then you could know any kind of, you just need to know what you want to know on your local machine. So if you work with JavaScript on your local machine, then that's everything you would need to know in order to go to AWS and learn it. So the only thing that you would need to go is to learn it is to understand how AWS services work, what it does, what is the use case for each service. And then here you could apply whatever external knowledge to it. Yeah, there are lots of training there for AWS. Some of them are for free. I'll be happy to share some of these trainings with Halim later, and he can share them with the group. Yeah, but yeah, there is no kind of specific, we cannot be very specific about this question. It depends what you would like to implement and what you would like to do.
Right, thank you, Ali. Next question is from Selena. She said, aren't cloud-based services more prone to glitch? And what is your opinion about this? And is there any way to avoid this?
I don't think, okay, so I don't think they're more prone to glitches or errors. I think on the opposite, there is a huge set of engineers and huge set of resources that are handled by AWS or cloud providers around setting up these services and making them working properly. So I would say these services kind of work in a proper manner. However, as any software, they might have errors, they might have bugs, they might have defects. And here, I believe there's lots of some kind of plans and some kind of ways to handle these kind of errors from AWS, such as in case, for example, a data center went down, then they have another data center to take care of the things. And there is some kind of replication of services and all of this. So I think it is more reliable than on-premise, in my opinion, because you don't really need to care about your server, right? So I mean, if you are working on your own data center or in your own servers on your company or in your house, then you would have to have a server. And then in order to make sure that nothing goes wrong if your server went down, then you would need to create yourself another server that is going to have like some kind of replication of services and data, right? And yeah, this is a lot of work. And even if you want to handle it through virtual machine on your local, also this is lots of work. You would need to like set up tools such as Hyper-V or VMware and whatever to handle this kind of virtualization. So yeah, I think like I would personally prefer like to go to the cloud. I think nowadays most of the companies are going to the cloud. Even very big organization kind of go to the cloud. It's pretty secure and it's pretty reliable. So I think like the risk is way lower than having your own servers running on local. I'm not sure. I hope I answered the question. Yeah.
Okay. Thank you, Ali, for that. Last question from Petrus. He said, last question from me. The development process must be done inside of the AWS environment, or is there a way to bridge our local development environment with remote AWS environment? Also, is version control systems supported?
Yeah,
for example, Git?
Yeah, very, very good question. Yes, so now I just like demoed everything in AWS and inside of AWS, but I wanted to go into the code. And as you can see here, I am using VS Code. You see, so here, like I am preparing everything here. And even for the deployment, I don't need to create the Lambda manually through button click in the code. So here, everything is written as infrastructure as code. So as you see here, I have a YAML template where I have defined my Dynodb table and what is the company and what are the primary key, company ID and company name. Then here I defined the company API. So as you can see here, everything from infrastructure or resources can be defined as code, and then you upload this template into AWS. It's called CloudFormation, and then CloudFormation takes care to create all of these resources for you. And then, for example, here I have defined that my Lambda, it goes to, it has this handler, app.handler. So I have defined like where the code lives. And if you go to app.js, you can see this is my Lambda handler here, and all my code is written on my local. And this is how I'm trying to access it. And I do scan and filter data from the database. So yeah, everything could be run on your local, and you could use whatever version, version. You could use Git, for example, and you could use GitHub or anything else in order to store your code. And then here you could have like some kind of command line or some shell scripts in order to push your code every time you change it. So for example, if you look here at package JSON, so here I have a deploy, a build and deploy, and then it has a command where it's actually building and then it's doing SAM deploy. So this is a serverless application model. It is like some kind of a command line from AWS as well to deploy the capabilities. So every time I change, I just do npm run deploy, and it's going to deploy all of my code into AWS.
Right. Thank you, Ali. Again.
Sorry, one question. My VS Code is visible, right?
Yeah, it is visible.
Yeah. Okay.
Okay, cool. So next to the final question from Celine, I think if this VS Code is an example, can we have it?
Yes, of course. I'll send you the link. So look, I'll send you like the link for this GitHub. I'll send you the slide point. I can send them to you on LinkedIn afterwards, Halim. And
sure.
So the code for this and the GitHub code, the slides, and I have written a blog post about this specific project which details it. And like this project that I have here has a bug in it. So if you are really keen, have a look and find the bug and try to solve it. Create a pull request on that GitHub repository. And if you'd like to discuss it, just message me on LinkedIn or Twitter, and I'll be happy to collaborate with you to get it implemented. Yeah.
Okay. Now to the messages. First message from Petro. He said, "We need more." Thank you, guys, and great presentation. Second message is from Mimi S. She said, "Thanks for the great and gentle introduction to the cloud computing and AWS. Awesome to be part of the community that is eager to learn and to." Sorry, I lost the messages. Okay, that is eager to learn and to share. Okay, and then the next message is from Selena. "It was really open-minded introduction for me that I never saw AWS again. Thanks a lot, Ali." And the next message is from Petro. "Great presentation, kind regards." Next, Irena. "Thank you for the introduction. I'm now interested to try AWS." That's, I think, an answer for a question. And we have Ammar. He said, "Thank you, Ali and Halim. Have a good evening, everyone." And we have the last message from Gerald. He said, "Very good and interesting presentation." Finally, a message from me. Thank you, Ali, for your presentation, and thank you for helping us understand the basic concept of AWS. And we are so honored to have you here with us in our community. And we would love to maybe have another webinar, maybe with you, to elaborate more on this subject.
Yeah, thank you so much. It was a pleasure to collaborate with you on this. I'm so happy I got the opportunity to share some of my previous learnings. Thanks for all the questions, like very interesting and smart questions, very challenging questions. I'm very glad that like I was able to make it today, and hopefully we can collaborate again in the future. Thank you.
Thank you, Ali. And for everyone, thank you for joining us today. And if you join it late or for some reason you have a connection lost at the middle of this, you will find this in our YouTube channel with all the resources in the description. And for our students, you will find all the resources that Ali mentioned in the resources channels. And that's it. I think see you next time. And goodbye.
See you, everyone.
Goodbye. Goodbye.
Bye.